This week, our focus is on time series analysis. Time series analysis is simply we're trying to forecast something, and time series analysis becomes our independent variable. Now, what do I mean by becomes our independent variable? When we're discussing time series, I'm looking at, like here in my Excel spreadsheet, I have year. That is a dimension of time. We could have quarter, we could have month, we could have week, we could have daily. So when I'm talking specifically about time series analysis, the dimension of our independent variable will always be time. So under time series analysis, yes, we're trying to forecast, like here, I'm going to try to forecast sales based upon my dimension of time, year. So in time series analysis, I'm only going to have one independent variable or one predictor variable, as opposed to what we just got done going through and under linear regression, multiple regression, and stepwise regression. In under multiple and stepwise, of course, we had more than one independent variable. But coming over here to time series analysis, I only have one independent variable. One other thing in regard to my year, you can see I've done 1, 2, 3, 4, 5, 6. In effect, I've coded. 6 could be making reference to 2018, and I'm trying to forecast sales for 2019. So just keep that in mind. It's a whole lot easier when we kind of code our dimension of time. So let's kind of go through the procedure. In the procedure dealing with time series analysis, you will need your QM. If you haven't already downloaded the QM software, kind of go back into Moodle, go back into the resources at the beginning of the start of the course. Make sure you download QM. You can download the QM. I believe I do have a video up there that will illustrate how to do it. I'm in a Mac environment, OS environment, so that's what I'm going to be taking you through. But when you download it, you can download it to your PC or to your Mac. But you're going to need the QM to do this assignment coming up and to do the work really from here on out. Because next week we're going to get into linear program, and the following week we're going to get into statistical quality control, which you will need the QM. So again, I know I'm being redundant. Make sure you get the QM downloaded into Excel. You must have Excel in order to download the QM. So once you do that, you can see up here I have Excel QM, and you'll be able to find that. Let me be redundant one more time. I'm in a Mac environment right now. So if you're in a PC environment, it may look slightly different than what I'm going through with my Mac. So when you find the Excel QM, click it on, and over here in the left-hand corner, you're going to see QM menu, menu. So in the PC environment, it'll be slightly different. It'll be by alphabetical or by chapter. So I'm just going to go here, QM, and forecasting, okay, drop down menu, and you can see everything how we're going to utilize in order to forecast. I'm just going to go through several. Here I'm going to do a moving average. I click on moving average. We can say title, give it a sheet name, and I'm simply going to say a 1 period moving average. And it's asking me for the number of periods in my data. Well, I got 6. So, and then it's number of periods to average. Well, I just indicated I'm going to use a 1 period average, which is not really a true moving average, more of a naive, because all what we're doing with this moving average is that we will lag by 1 our sales volume. So just keep that in mind. It's not a true moving average. It's a naive When I'm talking about a 1-period moving average, I'm lagging by 1. If I had a 2-period moving average, I would be lagging all my data by 2. Here we have some options, tracking signals, and graph. I'm not really going to get into the tracking signal. A tracking signal is simply this, i.e., from the standpoint, we're going to come up with the best forecasting model. And in this exercise, we will use a 1-period, we'll probably do an exponential, and I'll do a regression trend. So of those 3, I want to come up with the best one that I possibly have to forecast. And as I go through, I'll indicate how this is done in time series analysis. So just keep that in mind. I'm forecasting. I want to use the best method possible. So the first method is this 1-period moving average. So again, I've indicated the number of periods. We can probably go back and, if you want, change that periods to year. We can ignore for the time being the tracking signal and the graph, and we can say OK. And up comes a drop down. And one of the things about QM, very, very user friendly. All what we have to do is make sure that we input the data properly. And so basically, let's just go ahead and do that using the data, 8, 11, 12, 10, 15, and 13. Oops, really goofed that up. And 13, go back to verify to make sure that I have everything 8, 11, 12, 10, 15, and 13. Okay, got my data, and bingo. I have everything else here. Let me just kind of spread some of this out so you can see it. Okay, as I said, in time series analysis, I want to come up with the best forecasting model. And I'm going to go through 1-period, exponential, and trend regression. So of those 3, I have to choose one to forecast what my sales will be for year 7. So what we will do, very straightforward, is that I'm simply going to focus in on standard error. So in this particular case, my standard error is 3.78. 3.78 for my 1-period. It's an error factor, right? In other words, just think of it this way. In other words, I have, in this case, if we look over here for year 2, remember, 1-period is simply lagging everything by 1. 8 will be my forecast for year 2. 11 is my forecast for year 3, etc. So my error, you can see what's my error. My actual was 11 for year 2. My forecast is 8. I have an error of 3. So what we're doing here when we're focusing in on the amount of error, of course I don't want any error. Just going back, looking at regression, right? That's why we focused on the coefficient of determination. That told us what is being explained. So really, in forecasting here, looking at time series analysis, I'm focusing on my standard error. I want my standard error to be as small as possible. So, of the 3 methods, 1-period, exponential, and trend regression, I will choose the method that has, the least amount of error. In this case, the standard error. So, I will simply jot down 3.78. So therefore, I'm going to come back here to my data. And I'm going to go now back to my menu, forecasting, and I'm going to look at exponential smoothing. And I will say exponential. And I guess change that to years to be consistent. And I will say OK. And once again, I get a drop-down menu. Now, look here at alpha. Exponential smoothing is a weight mechanism. Think of a moving average. 1, 2, 3, 4, 5. The average is 3. Each of the values in 1, 2, 3, 4, 5 to come up with that average of 3 is weighted by, you might say, 20%. Equal weighting. In exponential smoothing, we are giving more weight to the most recent value. Therefore, we have 6 years. Year 6 is going to be given more weight than year 1. It's not going to be uniform, as in, we'll say, a simple moving average. So in alpha, we typically use 0.3 or 0.5, depending upon the situation. So I'm just going to say, okay, 0.3. So just make sure you put 0.3 down. And then we have our demand. Going to go back to my data. And I'll just copy, coming back over here. Paste that in and spread out my numbers. And okay, exponential. I'm focusing in on the error factor. Error factor is 3.44. So far, if I just had two, the 1 period and exponential, I would select the exponential as the best forecasting model, just due to the fact that what? It had the least amount of error. So my forecast would be, if I'm forecasting year 7 what sales should be, it'd be 11.89. Okay, very good. Okay, let's go on to really the last one I wanted to illustrate. Go back to forecasting. I wanted to come down to regression trend. Regression trend. Once again, I'm 6. And here I'll give it a name. Regression. And I will, years. I will say okay. We have our little menu. We have our little Excel sheet here. My demand, okay. Sales. Now keep in mind, right? We're doing regression. Regression. Sales is my dependent variable, will be equal to, some kind of mathematical formula. Okay, the mathematical formula will be the equation for a straight line. Time is my only independent variable. So here, we're just going to use the codes. I'll just put that in 1, 2, 3, 4, 5, and 6. And 6, okay? Let me straighten this out again. Make my, and what do I have? Well, once again, focusing in on the amount of air between my sales and my dependent variable sales and my independent variable year, and my error factor is 1.73. Okay. 1.73 is the forecasting model method of the 3 because it has the least amount of error. So my forecast, what I would say is, that proverbial bottom line, the best forecasting model method to use under time series analysis when I'm thinking about using a 1 period exponential and a regression trend is regression because it has the least amount of error. So that forecast for the 7th year would be 15. And you can see what is given here. I have my correlation, coefficient of correlation. I have my coefficient of determination. I have my intercept, and I have my slope. So I could write out the equation, right? It would be sales is equal to 8 plus 1 times year. So there you have it. That's really time series analysis. Time series analysis, forecasting. In our time series analysis, we're utilizing the dimension of time to forecast. So this is just kind of a quick overview. Hopefully this will assist you as you do your assignment this week over forecasting.